fingerprint of the message, and if you see that a message has the hash value that you expect, then you know it must have been the same message. Okay, so to sign his message, Ein first computes the hash value of the message, and then finds an inverse modulo 2RS. Ein knows R and S, but they're secret because the primes P and Q are secret. And finally, his signature is obtained by raising the T. T is part of his public key. T is publicly known the same way N is. So T is the public part of the public key, and so he takes T and raises it to the H hash power. Okay, so Ein sends S along with the message. Now, after Bin receives both the message M and the signature S, she computes two things. She first computes the hash value, H, for the message, and then she raises the signature to that power, modulo N. Now, and then she asks, is this equal to T? N and T are publicly known. N and T are the public key that Ein has. So she can do all of this. She can compute the hash value for the message, nothing secret about that, and she can raise the signature to the power of the hash value modulo N. If this agrees with T, she is satisfied that Ein sent the message because only Ein could have computed that value of S, because you have to have an inverse of the exponentiation by H map. Because the exponentiation by H map gives T back again. And that means to get S, you have to have the inverse of that map. And Bin knows that only Ein possesses the secret key that enables one to find the inverse. That is, finding H hat requires secret information, requires R and S. And Bin doesn't know about R and S, but what she knows is that the only way to invert this function is to know the secret information. Therefore, Ein must be the person who did that. Oh, also I should say that she also knows that the message was not tampered with. Because if the message was changed to some other message, that would automatically change the hash value, because nobody would be able to change the message in such a way as to keep the hash value the same. So this actually assures Bin of two things. First of all, that it truly was Ein. Second of all, that the message was not distorted. There's also a third property of digital signatures that's very important that this is good for, and that is called non-repudiation. Non-repudiation means that Ein could not later claim that he did not send the message. That the signature is so much connected with him. Okay, so they prove that this is provably secure against existential forgery under chosen message attacks, which is considered the strongest type of provable security result. So they said this was an improvement over earlier RSA type signatures. The most important thing for them is that they did not need a particularly strong randomness assumption about a hash function in order to achieve this result. That is, they could use an assumption about H that was quite reasonable, a collision-free type of assumption. They didn't have to assume a very strong form of randomness in order for their proof to go through. So they were able to prove a strong result under a weak assumption, and this mathematically sounds very good. However, so at this point, this looks very good from the standpoint of mathematical modeling. They have the strongest, what's considered the strongest type of provable security result under a somewhat weaker assumption than earlier authors. However, suppose that these signatures are used in an online lottery, which is an application that was not thought of about 20 years ago, or 25 years ago, when the definition of a secure digital signature was developed. Now, one way to set up an online lottery is so that each person chooses a number and then signs it using a secret key that no one else knows. If the number wins, then the lottery authorities use the person's public key to verify the signature and award the money. I'm somewhat oversimplifying things. You need a certain structure of certificates to be sure that people are getting their keys and are not doing various strange things with the keys. But so this is a slightly oversimplified description of how it works, but it's essentially correct. Now, there's an attack that Menezes thought of called the duplicate signature key selection attack that would enable a thief to steal your lottery winnings. And it turns out that the Genero-Halevi signatures are especially vulnerable to this attack. They're the most vulnerable signatures we know of this attack. So suppose that a third person, C. Chow, sees the winning lottery number and the signature S. He wants to convince the lottery authorities to give him the money. So he wants to claim that S is his signature on the message M. So he quickly generates his own RSA modulus N prime and chooses his T prime. It's more or less random, but he actually chooses it by taking the signature and raising it to the hash value power modulo N prime. So he generates keys for the specific purpose of claiming that S is his signature. And he does this quickly, and he gets his keys certified quickly, and he rushes to the lottery authorities before Ein gets there. And they will give him Ein's money. Because his signature, it's a duplicate signature that still verifies. When Ein arrives, oh, no more money left, sorry, someone already took your money. So it's kind of serious. So they are provably secure in the sense of a widely accepted mathematical model, but they are very insecure in certain applications such as lottery. Now the problem is with the security model, that is, the mathematical definition of what it means for signatures to be secure. In traditional handwritten signatures, the main security issue is forgery. So when mathematical models of secure digital signatures were first developed, the main model was based on preventing forgery. That was the central issue. And with handwritten signatures, it's very unlikely that a thief would claim that someone else's signature is actually his signature. It's hard to think of a type of fraud where someone else would say that that's is actually his signature with conventional handwritten signatures. So nobody until Menezes in the late 1990s thought that this type of security threat. But digital signatures are not entirely like traditional ones. So they're not directly linked in some physical way to the person. They're not linked to their handwriting or to their body in any way. And also someone can obtain many different keys, public secret key pairs, and any of them can be used for digital signature. So you don't have just one signature. And even more important, there are new applications of digital signatures that were not possible for handwritten signatures, such as digital lotteries. And the early researchers did not anticipate this. So no one thought of a situation where a thief would use duplicate signature key selection to steal someone's lottery. I should note, by the way, that the researchers still have not publicly admitted that their model is deficient, even though this is a published attack. Unfortunately, in some areas of science, people are very slow to admit when they make mistakes. It's very different from mathematics. In theoretical mathematics, anyway, if somebody finds an error in your theorem, in your proof, you admit it immediately, you thank them, you try to fix it. You don't deny that there's an error. Okay? But unfortunately, in some areas of science, people will first of all, try to deny and try to avoid the issue or pretend that it's not important and hope that nobody notices. Now, I should say that in practice, if you design a digital lottery, it is not hard to include features that prevent this type of attack. However, the industry standards for digital signatures do not require that to be done. There's nothing in the industry standards that require that. And people were being told that certain types of RSA signatures were provably secure for any application. The term provably secure was being used, so it should work for all applications. So it would never occur to them that they need further measures. Now, Alfred Menezes and I have a series of papers, we have a website devoted to it, where one of the papers, another look at security definitions, has the details of this. Our Another Look website has a critique of many issues of mathematical modeling and cryptography. The main purpose we have is to explain the limitations of mathematical proofs in the cybersecurity area. And in fact, we believe that the whole term provable security is misleading because you can't have a mathematical proof related to something that's secure. For example, another type of problem with mathematical security models is the possibility of so-called side channel attacks. So here, the enemy measures timings or emissions of radiation or amount of power consumed by a cryptographic device in various stages, the results of sending signals and causing errors, causing faults, and so on. So as an example, the usual double and add algorithm for, say, multiplying by an integer, multiplying a point on an elliptic curve by an integer, or exponentiating in a finite field. There's a standard double and add algorithm where you want to exponentiate by an integer written in base 2. Such an algorithm takes more time and uses more power every time it works with the 1 bit rather than when it works with the 0 bit. So in some cases, a side channel attack can determine all the bits in the secret key by making careful measurements. So now, let me return to the question in my title about whether mathematics can provide good models for society. And I want to talk about a different sense in which mathematics does offer an excellent model for society, a very different sense. I think this is that it uniquely has offered society models of rigorous thinking and freedom from bias. And this is true of theoretical as well as applied math. So I think when we look at this point of view, we have a very strong argument for supporting not just applied math, but theoretical math. I think that is the main reason why the public has confidence in the use of mathematics as a means of selecting students for university admission. And that's also the main argument for teaching mathematics at a high level to future citizens, not just those who are in professions where they will have a direct use of mathematics. For example, in the United States, students who apply to a good law school are more likely to be accepted if they receive high marks in mathematics than if they receive them in political so-called science courses. And the reason for that is because people in law school know what I was saying about political so-called science. They know that in the first case, if they are students of mathematics, they are likely to have learned some habits of rigorous thought, whereas in the second case, in political science, rigorous thought is likely to be totally absent from their program of studies. So another example of the unique role of mathematics, communication with extraterrestrial intelligence, is another illustration of this. Mathematical languages have been developed for any possible future need to communicate with intelligent beings from other parts of the galaxy. Why mathematics? Well, because it is really the only universal language. This image is likely to be understood by any intelligent creature in the universe. And that's a unique feature of mathematics. Okay. So, anyway, so now I want to look at some historical examples of what I call freedom from bias in mathematics. Now, of course, I don't want to exaggerate about this. Mathematicians are human beings with human weaknesses, and we sometimes make terrible misjudgments and allow our emotions or prejudices or moods to affect our mathematical judgment. But I think that's relatively rare in mathematics compared to most fields, in my experience. So here's an example which I think is a really nice example from the history of mathematics, when Gauss is writing about Sophie Germain, saying that when a person, a woman, according to our custom and prejudices, encounters infinitely more difficulties than men to familiarize herself with these difficult research. And when such a woman succeeds in surmounting these obstacles and penetrating the most obscure parts of this research, then without doubt she must have the noblest courage, quite extraordinary talents, and a superior genius. So a really remarkable, you wouldn't necessarily expect it by a prominent German academician of his time to have such understanding of the circumstances of women and the need to encourage women going into mathematics. And Sophie Germain was pretty much the only woman at that time who did. Another famous example is Sofia Koblitz, who was the first woman in modern times in any field to become a recognized equal leader of the world academic community, the work of international academic research. So there was no one in literature or philosophy or even physics and chemistry of that stature. Another example of the special role or something so special about mathematics is the relation between G.H. Hardy and Ramanujan. Again, it's sort of inspiring to read, just as it was inspiring to read the words of Gauss about Sophie Germain. It's also wonderful to see the way Hardy wrote about Ramanujan. And here's his famous words describing his reaction to some of the formulas that Ramanujan sent him in 1930. He said that these particular 4 formulas are on a different level and obviously both difficult and deep. I had never seen anything in the least like them before. A single look at them is enough to show that they could only be written down by a mathematician of the highest class. Now this was a time when India was a colony of Great Britain, and most English people had racist feelings of superiority toward Indians. And normally, British intellectuals did not speak of Indian intellectuals in such terms. But in mathematics, we have this wonderful example of the collaboration between G.H. Hardy and Ramanujan. Now, going to our day, I think there are many people from poor countries or impoverished groups who see mathematics as a way to advance themselves, as a way in the modern world. In part because studying mathematics is accessible to anyone, in some sense. So a mathematician in Peru told me that some of the most enthusiastic participants in the Olympiads in Peru are members of minority groups such as the Quechua Indian people. The what?
Website in Vietnam.
Quechua is a website in Vietnamese. Okay. Yeah, Quechua, it comes from, Quechua is the name of the language, from before the Spanish conquest. It's an Indian group in Peru. It had nothing to do with Vietnamese. Okay, so it looks like Vietnamese.
My home country. Quechua is Vietnamese, means
my home country?
My home country.
Really?
Right.
Next time I'm in Peru, I will tell. We go to Ayacucho when we go to Peru, and that's a Quechua district. I will tell them that we is the home country for
people from Guyana.
From Guyana?
Yeah. Only from Guyana.
Local language.
Just a local term.
Local language.
So from Guyana. Well, I'll tell them from Guyana. And Ho Chi Minh came from Guyana. Okay, so I'll tell them that. Then they will be pleased. Okay. So at the Olympiad in Hanoi in 2007, the best performance on Peru's team was a boy named Daniel Sonko, who was a Quechua boy, who won a silver medal, who was the best of anyone on the team. And I learned that you also have an example like that of a boy from the Nun ethnic minority who won a gold medal in Germany, which is really very good, and it's another example of what I'm talking about. And I hope that in the future you will be able to use that example to inspire more ethnic minority youngsters to go into mathematics. I think that, especially when you have somebody who's that brilliant, you can have a program for ethnic minorities and hire this person to be a teaching assistant and help inspire other ethnic minorities to want to become mathematicians. So just as in Peru, I think in Vietnam, there can be a special opportunity to develop mathematical talent in the ethnic minorities. So mathematics, in other words, has a strong internationalist tradition. And people, mathematical colleagues can get along very well even if they are from so-called enemy countries. I think during the Cold War, the field that had the best relationship between Soviet and American researchers was mathematics, of all fields. And at another example, at the International Congress of Mathematicians in Helsinki, I was present at a very friendly meeting between Professor Huang Cui and S.S. Chern. And they were talking about desiring to improve contact between Chinese and Vietnamese mathematicians. And this was at a very, very bad time for relations between China and Vietnam, as you know, at a terrible time. But nevertheless, mathematicians could talk about improving their relations independently of what was happening in the political sphere. I think mathematicians have a natural interest in overcoming prejudices and hostilities and contributing to peaceful cooperation, even during political conflict. It's a very characteristic feature of mathematicians to have an international outlook. The final topic I want to talk about is a delicate problem here in Vietnam and in many other places. It's what I'm calling internalized colonial thinking. Some scholars who've written about related issues, the Palestinian-American scholar Edward Said, Algerian-French writer Frantz Fanon, Brazilian educator Paulo Freire, have written in the last century extensively about the influence of colonialism on people's psychologies and how they think. A common form that this internalized colonialism takes is for people in the former colony to believe that everything in their own country is inferior and that true standards of excellence can be found only in the Western country that used to be the colonial masters or occupiers. So let me give two examples from my own experience in Vietnam. The first example is an impression of our hotel. When we first came, Ann and I came first in July of 1978. And our impressions were generally very positive of Vietnam at that time. Of course, Vietnam was extremely poor. But our impressions of the social environment in Vietnam and of the people and of the way people were working and progressing were very positive. However, there was one very negative impression we had. And that was when let me tell the story. We were moving into the Hotel Thăm Loi on Hotel in Westlake, and Quai and Wong Nong Dok Chow were coming with us to move us into the hotel room. And I asked them to come to our room to talk. You know, we usually would sit around talking. In those years, we were always talking in Russian and telling stories and having a good time. But unfortunately, it was not permitted then for Vietnamese to go to the hotel room of the foreigner. So they explained this to us, and so I said goodbye, and they started to leave. And then the hotel personnel started yelling at them, yelling at Huai and Chow. And why are they yelling at you? Well, it turns out that the hotel personnel wanted Huai and Chow to carry our bags for us to our room and then leave.
No, it's not the colonization, but maybe a lack of security. Because at the time we have a very limited contact with foreigners.
Yes, I know, and I knew that at the time. I was not angry because you could not come to our room. I understood that. I understood even in Moscow at first we could not come to our room. You had to get permission later. So I already knew about this.
Ambassador. It's the room of ambassador for all students.
Yes, okay, but I knew about that. That's not what I was angry about. No, I accepted that. I knew that it was very soon after the war, there were security rules, and therefore I was not angry that you could not come to our room. I was angry that the hotel people expected you to carry our bags for us, and like our servants, to our room. That is internalized colonial thinking. And so, in other words, there was this situation where Vietnamese hosts of foreign visitors may not go to the room to talk to the foreigners as equals. However, they must go to their room in order to carry their bags and suitcases for them. And I remember writing back to Moscow, our friend, the geologist, Wendin Suyen, who was in Moscow, and I remember writing, he asked me to write about our impressions. And I wrote about a lot of positive impressions, but I also remember writing, I was very angry about this, and I wrote about this and said, why, after such difficult years of struggle against colonialism and imperialism, and then in the hotel, they act like Vietnam is still a colony of France, and people should be treated this way. So I was very angry about it. I was young then, so I easily became angry. In any case, that's an example of what I call internalized colonial thinking. Long after Vietnam was no longer a colony. Another example is some of the reaction of some of the bloggers to my criticisms of the Vallely report in 2009. Their viewpoint was that Vallely was correct to ridicule Vietnamese government leaders and insult Vietnamese scientists. These were people in Vietnam who were saying this. Okay, let me just now talk a little bit about this internalized colonial thinking, and basically this point of view that things, especially in science and education, are so much superior in the West, especially the United States, and so inferior in Vietnam. So this cultural comparison is being made by some people. So I want to talk a little bit about the cultural comparison. Well, one thing before I start on that, just mention that perhaps the most obvious counterexample to the claim of that the U.S. is on such a high cultural level in science and education, and Vietnam is on such a low level. The most obvious counterexample is the attitude toward education and toward teachers. Now, in the United States now, if you go into a school, a typical American school, you will be shocked at the way teachers are treated, the lack of respect for teachers, the disorganization in the school, the disorganization in the classroom, the lack of attention to academics. Not only foreigners, when foreigners visit American schools, they are always shocked. But even Americans of an older generation like I am, I'm shocked when I go into our schools because they didn't used to be like that. And I've also visited schools in Vietnam and in other countries, and it's completely different. Teachers are truly respected. Here, November 20th is an important day in Vietnam. And in America, I don't even remember anything happening. There is a day of the teacher, but I don't think anybody pays it any attention. So in the United States, the teaching profession is a very stressful, unpleasant profession in many ways. They have a great deal of difficulty attracting intelligent young people to become teachers for that reason. That's a major problem we have. So that's the most obvious counterexample, is the attitude toward education among the masses of people, which in the United States is a really serious problem. In Vietnam, it's very impressive what people feel about education and about teaching. Let me give another example. According to various studies, roughly 1/2 of our population in the United States refuses to believe well-established scientific facts such as evolution and biology because they conflict with religious beliefs or superstitions. And in fact, I think 1/2 is a slightly low estimate. I've read that some people think it's more like 60% of the American population.